Cast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Yeah, I see everybody's joining now. So we will start. So I'm Pascal. I'm ETP4HPC's communication manager, and I'll be your host for this session. But I'm not alone today. My colleague Marcin is co-organizer, and he will handle your questions. So you have probably noticed that this webinar is in listen-only mode. Attendees can't unmute. And also you should know that this webinar is recorded. You will receive the link to the recording as soon as it's ready. So if this afternoon, if possible, otherwise, after the weekend maybe. And you will also receive the link to the presentations. So before we get started, I'd like to go over a few items so you know how to participate in today's event. On your computer desktop, you should see on the left the viewer, the GoToWebinar viewer, in which this presentation is displayed. And on the left, on the right, sorry, you have the GoToWebinar control panel that's pictured here on this slide. And that's where you can raise your hand. We won't be using this today. And you can ask questions, and we will be using this today. So you can submit text questions to the presenters or to the webinar staff by entering your questions in the question panel. You can send in your questions at any time during the presentation. Marcin will answer immediately whenever possible or relevant, and we will keep questions of interest to all for the Q&A session at the end of today's session. But we're tracking all questions, so we'll make sure everything is answered. Even if we don't have time during the webinar, then we'll do it later on. Just a short practical thing. The attendee panel, it collapses automatically when you don't use it. So if this happens, don't panic. You will, if this happens, you will only see the icons here, and you just need to click on the orange arrow to bring it back. So here is today's agenda. Before I give the hand over to Jean-Pierre, our chairman, I would like to ask a quick question to all of you. This webinar is open to everybody, not just to ETP4HPC members. So I was wondering if you are or your organization is a member. Now you should see a poll, except it doesn't work. So I'm sorry about this. Come on. Well, it doesn't work. I'm sorry about this. Well, if I find out later on how it works, we will do it. Sorry about this. So back to our agenda. So we will have first an introduction by our chairman. So Jean-Pierre, I will hand over to you.
Hello. Hello,
Yes,
do you hear me?
We can hear you. I'm trying to switch to your slide.
Okay.
Yeah.
Good. Very good. So, well, good morning and welcome to everyone to this first webinar, which we just started today. Back in February, we had a survey among our members just to understand better what they would like us, what they expect from ETP4HPC. And following this survey, which actually was quite successful, we had a lot of feedback. There were two main takeaways. from this survey. And in summary, and you want more information about what's going on in the HPC ecosystem in Europe, and you will also like more opportunities for networking, for interconnecting with other partners in the HPC ecosystem in Europe. So this was the main driver for initiating these webinars, and we would like them to be on a schedule on a regular basis, and to cover all the topics that so far we've thought about. And first, I would be introducing our new members. I mean, you'll see the list of the members later on. We get new members every month. But also, and I think it's good for these new members to have a forum to explain what they're doing. Obviously, to cover some technical topics. And so, for example, we have a couple that are SRA related that we already prepared. Also understand what are the European projects. So by European project, we mean Horizon 2020 project or now Euro HPC project. Also meet our SME members. I mean, it's difficult when you're an SME to reach out to the community. So this we would like to facilitate this, and also talk about HPC and use cases. So we really appreciate if you can give us your feedback. You see here the address, webinar@etp4hpc.eu. Would like to understand, if you have any suggestion about the topics that you like to cover in the future webinars. I mean, the first couple already set, but for the future, and what frequency you like these webinars to happen. We were thinking maybe once a month. This is up to you to see how what we can do. Another thing, and Pascal already mentioned it, these webinars are open to everyone in the HPC community, but whether you're part of your organization, you're part of ETP4HPC or not. So I think it's a good opportunity for everyone to understand what's going on for the ETP4HPC and discover what's going on. Well, so we're looking for your feedback. Thank you. Next slide. Pascal, if you can, yes. On the next slide, so we're announcing, the second webinar, which is going to be in 2 weeks from now, again, on Friday at 11 a.m. So in case you're interested, you should register pretty soon. The registration, you'll see a message. And again, you can invite your friends. The agenda that we prepare for the next meeting, the one in 2 weeks, is obviously introducing new members, and here we have 3 that are listed: Ingenium Scale in France, Do IT Systems, which is an organization based in Italy, and European Open File System Association, EOFS. We also will introduce 4 SMEs that should have been on our booth at ISC. ISC was supposed to happen next week, but it's been cancelled or moved to an online event. And so the 4 partners that were supposed to be on our booth will have the opportunity during the next webinar to introduce themselves and present their products. And then we have a presentation about one of the Horizon 2020 project, Deepest, and the Mont Blanc 2020 as well. So this is the program for the next meeting. Be ready, and we welcome you next in 2 weeks. Just a quick summary about the ETP4HPC. As I said, it's growing. Currently, we are, by the last count last week was 98 members, but we already got a new application, so we'll grow to 99 and potentially above 100 pretty soon. As you can see, it's quite diverse. We have 39 research organizations, or almost 40% roughly. A group of SMEs, the very lively ecosystem there. and some larger global corporations, and the European also corporation. We have 6 of them. 2 associations, for example, EOFS is one of the 2 associations, and some individual who can who can apply individually. So as you see, it's moving, and you have probably all the big names for the HPC ecosystem in Europe. But I mean, there are probably another equivalent number of organizations that could join, and I hope will join us in the coming months, coming years. Well, okay. So so I just want to say, I mean, the 3 organizations that we'll be introducing today is Università degli Studi di Padova, if I pronounce it correctly, University of Padova, and it's a full member. It's a research organization in Italy. We have also Mathematical Methods and Models for Engineering, M3E, so it's a full member SME. And finally, DLR, which is a larger research organization in Germany, the German Aerospace Center. And I won't try to pronounce it in German because my German is very primitive. But I would like to.
Für Luft- und Raumfahrt.
Very good, thank you.
Couldn't resist.
Thank you.
Sorry.
Okay. Well, I want to thank you very much for joining ETP4HPC Association. We're really looking forward to your participation and your input, and this is always good to see new members bringing new ideas to the forum. I think that's it for my introduction. Again, welcome everyone, and we're waiting for your feedback for these webinars to improve them and to give them more meat. Okay.
Thank you, Jean-Pierre. Thank you, Jean-Pierre.
Yeah,
so usually we welcome our new members of the year at our General Assembly, but obviously this year it was not possible as we had no in-person General Assembly. So, well, we are going to have a few of them today and a few of them at the next webinar, and that way you'll be able to meet them all. So our first new member today is the University of Padova, represented by Professor Carlo Ianna. Carlo, are you with us? You have to unmute. Nicolo, can you please unmute?
Okay, sorry.
Now we can hear you. No problem.
So thank you for the introduction. My name is Carlo Ianna. I'm from Padova, from the University of Padova. I'm here to represent the University of Padova. The University of Padova, or Università degli Studi di Padova, as Jean-Pierre said before, is one of the oldest university in Italy. It was founded in 1222, and it is also one of the oldest in the world. It's one of the largest universities in Italy, and we have more than 2,000 faculty members. And Padova is a small city, and the University of Padova is a sort of industry for Padova, because I think it is the main industry in Padova, and it has an annual revenue of more than 600 million euros. So it has a good impact on the economy of Padova. And of course, we carry out research in several fields, from human sciences to medicine, biology, pure and applied mathematics, physics, and all the fields of engineering. It's a large university. And we also have a very strong link with the industry, with more than 100 spin-offs that have been founded from the university and then thrown into the industry. So we have more than 100 active spin-offs presently. Next slide, please. Okay, so within the university, I represent a research group in numerical analysis. This our research group consists of 6 faculty members and around 10 other people comprising a PhD or postdoc. So our research mainly concerns algorithms and softwares for the discretization of partial differential equations, and we are also specializing in algorithms and software for solving large and sparse linear algebra problems, which is strongly connected to the discretization of PDEs. We carry out a lot of applications, a lot of real-world application on complex environmental systems, and we carry out simulation both at the local and regional scale. So the main sector of the industry where we have a connection are, of course, the oil and gas industry, because we have a long tradition of study in geomechanics and reservoir simulation. We also work in subsurface hydrology. Our department is a department of civil engineering, so we have a strong connection with hydrology and mainly with subsurface hydrology. And also we carry out some application in structural mechanics. Personally, I'm a civil engineer, so I'm a structural mechanic. So this is one of the fields that I really like. Next slide, please. Currently, the most recent project that we have, first of all, we have a very strong and effective synergy with the spin-off M3 that will be presented soon. This is a spin-off that has been originated from our group, and we still have a strong knowledge, strong cooperation with them. We mainly work on the scientific part of the problem, but usually the more applied part is developed by M3 because they have more experience with the industry, with implementation, with of course with HPC. So we have a very strong synergy with them. And we have some open project with oil and gas companies, with specifically with ENI, which is the Italian oil and gas company. And we are currently developing a project on linear solvers for geomechanics and reservoir simulation. And we are developing solvers specifically targeted for their new HPC system, the HPC5 system, which is reclaim it is the most powerful high-performance computer for industry. So we are developing some algorithms for them, and we are also working on a high-performance tool for the regional modeling of the evolution of sedimentary basins. We, of course, model hydrocarbon reservoir and groundwater management in developing countries. And finally, we have an open R&D project on the discretization tools and the scalable solvers for coupled subsurface simulation of massively parallel system. And this is another R&D project which is in cooperation with the Stanford University and the Lawrence Livermore National Lab. So this is it, I think.
Thank you, Carlo.
If you want information, you can contact me, and you can see my address there. Thank you for your time.
Thank you, Carlo. So yeah, if you're interested, maybe, I don't know, in a collaboration with the University of Padova, do contact Carlo. You can also ask questions in the question panel, remember? For our next speaker, we will stay in Italy because actually we will stay in the same office because it's Nicolo Spiezza from M3E. So Nicolo, the floor is yours.
Hi, thank you very much. So yes, I'm here to talk about the M3E, which is this spin-off of the University of Padua. And M3E, as you can understand from the name, it develops algorithm and scientific software for simulation and prediction. So what we mean with scientific software, we mean that we can solve customer tailored engineering problem like algebraic differential equation or numerical algebra problems or optimization and calibration problems. And all these type of problems can arise in every engineering field, such as oil and gas, mechanical engineering, pipeline, biomechanics, and so on. So, as you understood, we develop software. It is a scientific software for mathematics, and it is applied in several engineering fields. But what makes us unique is that we create this software in order that they can run as fast as possible. So all our algorithms leverage on HPC platform. If you go to the next slide, please. You can see these are just some of some screenshots of our application. So you can see some hydrological application, oil and gas application, solution of linear system with huge matrices, but you can also see a screenshot of a pipe network. So what have all these problems in common? That we can solve huge problem of this type, up to hundreds of millions of unknowns. So if you go to the next slide, please. Okay, here in this slide, we try to figure out two types of collaboration, so two types of services, and I hope that this slide will help all the ETP4HPC community to understand how we can collaborate together. So usually we start from two different customer needs. The first customer needs, which usually apply to engineering company or research center. So the first case is that our customer has a deep knowledge of the engineering problem, but it doesn't have a software, a scientific software to solve this problem. For example, because commercial software doesn't exist or they are not reliable to solve this problem. So in case of this need, M3 can strongly collaborate with this customer and can implement a scientific software really customized for our client. The second case, the second line, is when our customer, again, or an engineering company or a research center, but also a software company. So in this case, they do have a software, they do have their own code, but usually they are not satisfied about the computational performances of their code. So in this second case, we strongly collaborate with these people and we make this code really efficient, really computationally efficient, either implementing better algorithm or either embedding our proprietary library products into their codes. And in this case, again, we leverage on CPU and graphical processing unit supercomputing. So I hope that you might be interested in one of these two opportunities of our SME, and we are really interested and open to start new collaboration with all the ETP4HPC members. Thank you for your attention, and you have all the contact information in the slide.
Thank you very much, Niccolò. So they will contact you. I hope many members will contact you. And thank you for the excellent timing. We are right on time. I love that. So for our last new member today, we are going to travel to Germany. Thomas Gerhold will present the German Aerospace Center. Thomas, are you here? Yes, I can see you've unmuted. Welcome.
Yes,
Go ahead.
Yes, I'm here. Good morning, everybody. So my name is Thomas Gerhold, and I'm head of the Department for High Performance Computing in the Institute of Software Methods for Product Virtualization in Dresden. I'm the DLR contact for ETP4HPC. Next slide, please. Okay, not our institute, but the DLR as a whole became member of ETP4HPC. And the DLR consists of 3 pillars, which is a research institution. The second one is a space agency, and there's also the project management agency. The research institutes, they are spread it over, these are 50. They are spread it over Germany, and you can see the locations, the 27 locations here on the right on the map. Currently, DLR has a little bit more than 9,000 employees. Next slide, please. Okay, the research areas of DLR, there are 5. This is aeronautics, it's space, transport, energy, and security. To present all that, that's not possible in 5 minutes. So please, if you want to see more details, go to the DLR website. The link is here written below. Okay, next slide, please. With respect to HPC activities, not all institutes in the DLR have HPC activities. There are mainly 6 institutes which are listed here, which are involved in significant HPC activities, I would say. So this is concerns research, development, and usage of HPC applications, and these are mainly the CFD solvers of DLR. There's TAU, which is quite good known, I think, for aircraft, external aircraft aerodynamics. There is TRACE, which is a code for turbomachinery, and there is CODA, which is a new development, started from scratch some years ago, but coming into service very soon. So we are working in DLR together with industry like Airbus, MTU, Rolls-Royce, and other users of our software. There are some more activities which are a bit smaller in DLR, so there are a few other institutes involved, and there are also institutes involved in HPDA activities, which are not listed here because of the time. Next slide, please.
1 minute left.
Okay. Yes, I see it. Okay, we have our own infrastructure, which are 2 HPC clusters. A new one in Dresden, about 2,000 nodes. The second one will be installed in Göttingen very soon. The achievement is ongoing, and it will be approximately the size of 1,000 nodes. Okay, and the last slide, please. Next. Next slide. Okay. Click again. This is, I will not go over that, but you can read it. My time is gone. That is a very brief description of our institute in Dresden, which is for product virtualization, mainly the aircraft and engine virtualization. Okay, that's.
Thank you very much.
It.
Thank you very much,
Okay.
Thomas. So the attendees will have the presentation, so they will have more details. And here again, I mean, if you have ideas for collaborations with DLR, do contact Thomas Gerhold. So thank you to our 3 new members, and you can ask questions in the question panel. I don't see many of them coming in. and we will have the Q&A session at the end of the webinar. So now we will transition to today's core topic, our Transcontinuum initiative. And for this, I welcome Michael Malms, who is a member of the ETP4HPC office and Grant Master of our SRA, Strategic Research Agenda. So Michael, can you explain what it is and how it started? And I know you have two guests as well. Michael, the floor is yours.
Yeah, so I hope you can hear me. Welcome to this webinar. And the three of us are happy to take you through a journey here, the Transcontinuum journey. So I'm not just by myself. François Baudin, professor at the University of Rennes in France, will help me explain what Transcontinuum is. François is one of the founding members of the ETP 8 or 9 years ago. And he has been very instrumental and helpful in writing the SRAs 1, 2, 3, 4. So he's very close to the work that we are doing in the SRA arena. And Zoltán Horváth, he is professor at the University of Győr in Hungary. And he just explained Győr is located in the middle between Vienna and Budapest. He is the head of the Department of Mathematics and Computational Science there. And he is also the SRA Grandmaster, as Pascal said, in the area of Euromass-In. And you will hear in a second what this organization is all about. And he will talk about the digital twins and digital twin use cases. The idea of this the next 30 to 35 minutes is that we take you through the definition and our understanding of Transcontinuum, so that when your partner wakes you up tonight at 3 o'clock, for instance, you can immediately speak for 30 seconds, explain what Transcontinuum is, and then fall back to sleep again. So that is the idea. Okay, next chart. So it's a little bit structured, the agenda. So first we'd like to talk about the word. What is this initiative? Where does it come from? And what type of horizontal collaboration do we foresee in this initiative? Then a bit about methodologies we'd like to use in order to do the work. And then also a view on the next actions over the next few months. Next slide, Pascal. And we start the journey at a point that we all understand. You have seen from Thomas the beautiful picture of supercomputer buildings. And this is what we understand. So data centers full with supercomputers is what we all know and love. Big machines to solve very complex computational problems in many different areas. I don't need to explain this because that is our bread and butter arena. But it's not the only one that is relevant in the future. So for instance, if you take the next picture, Pascal. On the right of this table, which is introducing the term digital continuum, you see here facility, data center, and exascale. That is where supercomputers are located. And this idea of a continuum was introduced by the project called BDEC, Big Data and Extreme Scale Computing. And this term has been coined many years ago, 4 or 5 years ago, and has been used to explain a continuum. So on taking from the right, going to the left, today's real world is much more governed by different instantiations of electronics. This chart here is a hardware picture. So on the edge, where you have sensors going back to the centers, you have many different levels of more or less complex electronics. And what is more or less constant is the product of count and complexity. So on the right, you have maybe only 10 big data centers. On the left, you have billions of small sensors. And this is, and in the middle, you have something that is called fog computing. And this picture introduces a fact that between the sensors, the many sensors spread around in cities, in cars in the future, in the industry, and the supercomputer at the center, there is a continuum of data flow and workflows. And so I would like now to ask François to talk on the next chart about the term transcontinuum. So you have you know now BDEC and you know continuum, but the word transcontinuum is new. François.
Thank you, Michael. Hello, everybody. So we'll just try to explain on this slide how we got to transcontinuum. So as Michael said, we started with HPC and 10 years ago with the ESI initiatives. The idea was we need exascale computers, which is another word for energy efficient computing, but only a few numerical model will use this kind of computers. So it was a capability design oriented to solve big numerical problems. And going on thinking about that, we got into the BDEC initiative, which was big data and extreme scale. And one of the idea there was the volume of data coming in and out of simulation. So coming in, for instance, from large scientific instruments and coming out as a result of the simulation were so large that you first cannot upload every data in the simulation to disks, to storage, and we needed to add high performance data analytics. And the question at that time was the convergence of the software stacks. How do we have a supercomputer numerical model stack, MPI, Fortran, C++, and so on, and the HPDA data analytics stacks. And so at that time, there was a question. We thought it was a question. And for instance, containers technology was very important for this. And while going on these reflections, getting more into the data focus, we got the term continuum. So the data are basically produced by a lot of ways, and they have to travel between systems. And so HPDI becomes, you needed to add to the cyber infrastructure, the cloud, the edge, the IoTs, and in a continuum of devices. And that vision, that was mostly BDEC 2, led to the current Euro HPC era vision, Transcontinuum, where somehow you need the applications are based on complex workflows that have a complex data logistics that must be spread over a large set of devices. And so the idea behind the transcontinuum is that if many applications will need to have a coherent view of the set of infrastructure involved in the deployment of the application through complex workflows, and so you see new words, for instance, cybersecurity. Nobody can trust connection between systems if cybersecurity is not handled well. The 5G is going to modify the way we connect things, and so on. And so the transcontinuum view tries to capture the idea that you cannot consider each infrastructure element independently. So what we're trying to see there is that if we want to do end-to-end applications, I will give an example just next slide. You need to be able to provide a global view, a coherent view of the set of infrastructure. That means a lot of coordinations between the different elements. So I just put a link to exascale.org, the BDEC, on the BDEC. All documents are available, all white papers, so you can check all meetings that have been held and get all the information that was discussed there. Pascal, can you move to the next slide? And so if I try to translate that into this transcontinuum vision into challenges, you start to see that there is many technical and scientific challenges. You need to consider that you will share the infrastructure. It will be multi-tenant. It's multi-owners. If you take the example on the bottom, which is one of our test bed to explore those ideas, the ACMO project. This project gather pollution data with sensors on buses. So we have less sensors and the bus moves the sensors around. And on the extreme end of the flow, you have supercomputers to do the pollution dispersions computations. In this picture, you have many different infrastructures. They are not owned by the same people. But if we want things to work, you still need to have an agreement on the way you connect things, and you give authorizations and so on. So it's heterogeneous, it's distributed computing, it's complexity in programming. The sensors are not programmed in Fortran, for instance, but the numerical model is. It's orchestrations and so on. So the data logistics here is quite complex, and you need to have ways to control, to get access control metadata. Resource allocation and orchestration, for instance, how do you allocate the resources? How do you build the use of the resources? How do you do urgent computing? We had a good example recently where it would have been nice to have urgent computing already set up with the Lubrizol in Rouen, the fire that happened in a power plant, sorry. And you need to be able to reconfigure things and so on. So cybersecurity is one of the keys there. If you don't have a transversal authentication, it's going to be a problem. You need to be able to monitor everything globally, not just independently. You need to be able to detect if there is some cyber attacks on the whole systems. You need trusted communications, some resilience, and so on. And one of the big topics coming in is AI everywhere. At the edge to improve data localities, that is, you want to build a model at the edge in order to limit the data you will transmit. You want also that, for instance, for privacy. So if you put sensors that are camera on the buses, you only want to get the output of the analysis of the picture. You don't want the pictures out. And you need AI for science, cyber infrastructure for AI for cyber infrastructure, and so on. And finally, sustainability is quite a challenge too. The energy efficiency has to be very high, not only in the compute, but also in the storage and also in the way we move data around. And moving data is very expensive, and so on. And of course, some training. So the Transcontinuum is actually a very a big challenge as a whole, and it has to connect many communities, not only HPC. HPC is only a small part of it now. It's a part of a bigger set, but science, if we want to do science on the cyber infrastructure, we need to connect with the cloud community, to the cybersecurity communities, the AI communities, the big data community, and so on. And I will finish here. Thank you.
Okay, thank you very much, Francois. And Pascal, you move to the next picture, which is a perfect representation of what Francois just said. He said you need many disciplines in order to implement these complex workflows. And we have this wheel. This wheel is now also depicted in our SRA, and there's text around this picture explaining this in more detail. So if you have looked at the SRA on page 15 to 20, you can read more about this. This picture, by the way, was generated some time ago by our partner project, High Peak. We'll talk about the interaction and the intertwining connections between these different areas over the next few charts. Pascal, you want to talk about
yeah,
I
mean, you mentioned the SRA and you showed its cover. So I like to live dangerously. I wanted to launch a poll to ask to our Attendees, no, it doesn't work. Okay, sorry. I wanted to know who among our attendees have downloaded the SRA4. So as the poll isn't working, can you raise your hands? You know, there is a raise hand button for attendees. Can you raise your hands? Those who, oh, okay. Oh, quite a few hands raised. Good. Okay. Well, those who have not raised their hands, the SRA is included here in the handouts in this webinar, so you can get the PDF here. Oh, well done. Oh, I didn't think we'd have that many. Thank you.
Okay, Pascal. All right. So thank you. We move to the next picture. Keep this wheel in the back of your mind. All right, so in the SRA as well, there is a text describing what Francois just said. So we're talking about this transcontinuum and about the need to collaborate between all the disciplines that contribute to this wheel. So we encouraged a horizontal collaboration effort. We started this some time ago, and this is explained in more detail now on the coming charts. If you want to read through this, please go to the SRA, page 97. You see what the vision is for this technical collaborative work in the future. Next chart, please. And this is now the this initiative. We call this Transcontinuum collaboration. And it involves 7 organizations by now. So we started with BDVA in the beginning and High Peak. I also already introduced High Peak. And then we understood, okay, we need cybersecurity, and ECSO, the European Cybersecurity Organization, joined. You also need, of course, 5G. This association is also part of this initiative. We talked about AI everywhere, and CLAIR is a network of scientists in the area of artificial intelligence. So they joined lately, and also EU Mass In, and Zoltán Horváth is representing EU Mass In today, and also in this initiative work. And why do we do this work, and what is at the center? So you see the 3 bullets down here. First of all, we would like to strengthen research and innovation in Europe to support this continuum. Given the fact that this continuum is so important, what kind of research should be undertaken in the future? This is our work. We define basically research focus areas that are in need of this kind of close interdisciplinary work. And basically 7 associations. Let's see if there are more to join. Next chart, please. And this, let me run you through this, this chart here. This basically is a model for how we approach this exercise. We first have this definition of this digital continuum. This is the text I showed before, SRA4, page 97. This is an abstract description of these challenges that Francois was also talking about. And in order to understand what the research and innovation topics and priorities should be in the future, you need to go through use cases. So you better focus on a few very important, relevant use cases that span the entire spectrum introduced by this continuum. And we did an exercise with a few, with one very prominent one called extremes prediction in the digital continuum, that is also described on page 20 in the SRA4. And we have others. Zoltán will talk about others that we also analyzed in the past to some extent. This work has just started. And so you look at these use cases, you understand how they work, you understand the workflow, the data flow, and then you can see, okay, where are the challenges? What is well understood? What is maybe in being developed, and what is still a big challenge? That is in the middle here. So you have to translate the use case into technical challenges. And then you are able to write up recommendations for calls, and we then go and knock at the door, for instance, of EuroHPC. So ETP4HPC and BDV are on the advisory board for the EuroHPC joint undertaking. So this is a natural way that we propose research there. And the hope is that some of our proposals make it then into work programs, in this case, 21 to 24. So this was our first approach. Then you might know that another GU is about to come up, called Key Digital Technologies, KDT. So this will be our next stop. And then, of course, the big area of areas and programs, work programs within the next multi-annual financial framework. And I have a chart on this. In that arena, missions are at the center of our interest. So this is what we want to do. We want to basically drive down through this set of levels here into very crisp and well understood recommendations for research to be undertaken in Europe, and then we will try our best to get some of this funded by organizations. Next chart. So, so this is one chart that shows this process of analyzing use case, and you see the wheel again, and you see this use case extremes prediction that I talked about before. And the first attempt was, okay, by the owner of the use case. So looking at this wheel, at the different areas, where are we good? Where do we have lots of work to do? And where are we in transit? And he said, well, let's use a firelight here. Between red, yellow, and green, describe the areas that we have to cover. So for instance, on the left, when you look to HPC and cloud, he said, okay, extreme scale computing. He said, for us, yeah, we understand this. This is coming. We need this. Not a lot of research there from our application perspective, but we need to generate digital twins. So this process of defining them, of programming them, of getting them into action is something that they work on, and the twins really is a totally novel approach for this use case and is shown in red here. So this is the first attempt of showing, okay, so what are the areas of real focus in the next time. Next chart.
We're running late, Michael.
Yes, I know. I speed up. Yeah. We also, this is just an FYI, since we're running out of time. We described in our recommendations to EuroHPC the use of digital twins in this Transcontinuum. If you're interested, I can send you just a snapshot on this chapter. This is not a public document, but if you're interested, you can certainly read through this. So, since we talked about digital twins, this is the key word for Zoltan to take over for the next 3 charts.
Thank you, Michael. Good morning, everybody. Just some words about the EU Medicine. EU Medicine is the European Service Network of Mathematics for Industry and Innovation. It's a Dutch foundation legally, but practically it's a network of national networks of mathematical research groups. By mathematical research group, I mean that these are interdisciplinary research groups, which are led some mathematical technologies. And 21 countries, 200 interdisciplinary research groups, and approximately between 1,000 and 2,000 researchers are involved in the activities of the EU Medicine. So We have an industrial core team with Siemens, Michelin, Shell, Bosch, Atos, Dassault, Norse, and Eco MT. And these are the core team members and more industries involved. Our main goal is to establish a one-stop shop for the MSODE technology in Europe. Then by MSODE, I mean the modeling, simulation, and optimization in data-rich environment, which allows us to generate model-based digital twins. And the other main goal that for this technology, the MSODE, we do services, and the other one is to coordinate and maintain a strategic research agenda for this MSODE. Just a very brief overview of it, that we have modeling, simulation optimization, uncertainty quantification, machine learning, HPC, big data working groups. I would stress one, the model order reduction. Maybe this technology must be put to the present technologies that we mathematicians can bring into the transcontinuity the most emphasis. The next slide, please. The model order reduction, which allows you to compose a much faster simulation. Even we have use cases when 10,000 times faster simulations appeared in under industrial conditions. And this is what we always understood into the definition of the digital twins, into the model-based digital twins. Sometimes people use this term digital twin or to some digital model or digital simulation. This is something else. This is a new era of the simulations, the digital twins. We understand by digital twins that this is a digital replica of complex physical assets, which integrates all data available from sensors and from historical data and sensors, make a reduced model on the price of losing a little bit from the accuracy, but to get a much faster simulation by using the technology of HPC and artificial machine learning, just to leverage business opportunities, for example, real-time monitoring and diagnostics, or predictive maintenance, and so on. And therefore, if we, for a physical asset from a bridge or for a motor or a turbine, we have a digital twin replica, it has a huge business value. Next slide, please. Here we listed only a few digital twin use cases that we at EU Medicine have long project-based researches started from FP7, Horizon 2020, and also directly from industry. The first category of these digital twin use cases are what I mentioned right now, the online health and lifestyle monitoring of complex physical assets. Here on the top right picture, you can see a digital replica of a motor. Digital twin-based control of processes is another category of digital twins that we use in connection with Industry 4.0. A third digital twin I mentioned is a digital twin for the urban air pollution that we have been developing in the Center of Excellence of ETP4HPC of the Hidalgo, the urban air pollution, which downscales the global and regional simulations from the Copernicus and ECMWF simulations for weather and climate, and we get very high resolution models for urban air pollution, 1 meter at street level in operational way, we can pre-process, we can set up this simulation, high-performance simulation automatically from OpenStreetMap. Here we use DLR products, Sumo, and other tools with sensor integration from vehicle-to-vehicle communication and from other sources. The digital twin for integrated circuits requires a lot of simulations, online simulations, when designing these integrated circuits. For example, to solve extremely huge linear algebraic systems. And the fifth I mentioned, digital twin of gas transport systems. There is a long-standing project series in Germany for the German optimization of gas transport systems, where each element of the pipeline and all stations are simulated in a hierarchical setting, and we are to make a digital twin for the whole European system. It's planned. These are just five examples of five use cases, use case categories for digital twinning, where we do online real-time simulations. I could mention here also digital twin atlas for human organs, just from another domain, and we have many others that are under construction.
Okay, Zoltan, thank you very much. Let's go to the final 3 pages. No, we skipped this, Pascal. This is taking too long now. We skip this and we skip the next one. Also, go one further. Okay, so another 5 minutes. So the reason why we talk about digital twins, just one last sentence on this topic, was that we think that this type of use case is a perfect example of use cases really taking into account a very powerful transcontinuum infrastructure. Now let's talk quickly about the scope and objectives of this initiative. So we talk about this, the collaborative work. I talked about the 4 bullets here. I would like to spend maybe 1 minute on the second one, interlock with European R&I funding agencies and programs. You have seen the other 3 ones. Pascal, next chart. So when you look around, so where is research that might have an impact to this continuum taken on? You first on the right, on the left, you look to the next 7 years of the time of the multi-annual financial framework. You dig through the different layers of this construct, then you end up on the left, on the very left in Digital Europe. You see that there are many initiatives here between artificial intelligence, high performance computing, cybersecurity, and so forth. So that is one target. Then you see Horizon Europe. In the middle, you see the Pillar 2, which has another set of work programs interesting for us. And then you see the 5 missions. 5 missions are new in this framework. And as you can immediately understand, beating cancer and working for the environment, given the Green Deal priority of the EC, this all takes into account a transcontinuum infrastructure. Now, the EC, just for you to maybe read through this, has issued a strategy paper lately in February talking about Destination Earth. And that is in more detail now a lot of research areas that are using targeting transcontinuum technology. And on a more national level, France and Germany, you have the Gaia-X project, which is basically an answer to this. I see this at least as an answer to this European Commission document. So we're going ABC, we're going to interface with all 3 of them. Next chart, and this is the last one. Okay, next actions. We are writing a 2-pager vision document between all parties involved to state what we want, where do we want to go, and what our intentions are, in order to have a formal document signed by all organizations that we can use when we approach official entities of the EC, for instance. And then we start reaching out to these different players. We have set up a working group, a second working group, to come up with a framework for doing the use case analysis in a more structured way. And we think that since we're talking about workflows all the time, a reference architecture for workflows, having, let's say, using the same terms, or let's say a set of architected terms that every discipline understands and supports, might be very useful. And then we'll certainly, over the next several months, analyze further on digital twin use cases, as Zoltan was explaining. So this is on our agenda, and I will be happy to keep you up to speed over the next few months. Maybe in the fall we can have another webinar, Pascal, showing
Sure.
the progress that we do.
Sure.
Okay, that was it.
Thank you, Michael. Thank you, Francois and Zoltan. It's now question time. So, Marcin, do we have questions to the presenters? I see we had a few.
Yeah, there's one question that needs to be answered by presenter, and I think it's Zoltan. So the question goes, which main changes do you see in how we design HPC systems in the data center as a consequence of the digital twins use cases? This is from Daniela Picarozzi.
Thank you for the question. Yes, this is a very important point, in my opinion, that with HPC we can simulate very fast models. For digital twin, we need real-time simulations, and to get real-time simulation of a very complex model, it is impossible even in data centers, or it is not cost-effective. So we have to make a reduced complexity model that can be run even on edge platforms. But how to get them? This is a mathematical technology called model order reduction. And with this model order reduction, we use very heavily the HPC, but the resulted model is almost the same accuracy, but can be run real time. So HPC is to support offline to make a digital twin which runs online.
Okay.
Thank you, Zoltan. So this is the only question that needs to be answered by presenters. So the rest is handled.
The rest is already handled. Okay. So, well, then we are coming to the end of our webinar. So I would like to thank all presenters, the new members, Michael and his guests. Once you leave today's webinar, you will receive a survey. So we would appreciate if you would complete that and provide your feedback. You will also receive a follow-up email, probably after the weekend, unless I'm ready earlier, with a link to view the recording of today's webinar, and you'll also get a link to the presentation. So on behalf of ETP4HPC and our presenters, thank you for joining us today, and have a great rest of your day. Thank you.
Yeah. Bye-bye.
Bye.
Thank you, Pascal. Thank you, all the speakers. Thank you, all the attendees. Have a good day now.